Welcome to side event 105, which is basically about IceCube, and we will talk today about the significance of data cubes in Earth observation, how data cubes can be used in machine learning using high resolution time series SAR data. My name is Muhammad Irfan Ali. I'm a machine learning engineer in ISI. So I've been working in ISI for now 2.5 years. And yeah, I've been mostly doing machine learning development and some machine learning operations as well. And apart from that, also doing some Python modules development. So working in a very dynamic environment and learning as I go. And my background is in actually electrical engineering. I did my bachelor's and then I studied in Aalto University. I did robotics and machine learning. So yeah, that's about it for my introduction. And maybe Agno, you can
Sure.
introduce yourself as well.
So, hi everyone. So, my name is Arnaud Duperrin. So, I'm working as a data scientist at ISI. So, I joined ISI 1 year, a few months ago, where I joined like the ML team. So, I worked on different ML projects, ML ops, and also infrastructure. But today my role will be like a bit different. So I will be in charge of like executing like Jupyter cells. We really wanted like to take the most of this like side event and just go with like a live example. Hopefully at the end of the live example, you will be like um, you will be interested by like using IceCube in your current processes. So yeah, that's it from my side. I will give back to Irfan.
Yeah, great. All right. So one thing I just want to mention here, I know that as if you're joining as a guest, you cannot really like just ask questions. So if something comes up, just put it on a chat, and then we will try to address it as soon as possible. So the agenda for today is, and this does not include the problem that we're into. So just the presentation, we will start with that. I will talk about data cubes, their importance, why they are needed in EO domain. And then we will talk about ice cubes, which is basically the data cubes that we're generating with the ISI SAR data and the building blocks of that. And as Agno mentioned, yeah, we will be touching upon ice cubes with machine learning example as well. I will also walk you through the GitHub repository that we have created as part of this project, and it is open source in Python. And hope you like the documentation that we have set up there as well. All right, so let's jump into this thing. Yeah, so as some of you might already know that this was a project that we did with the collaboration with ESA, and it was under AI for SAR project. And the idea was that we want to create an infrastructure that facilitates creating AI-oriented data cubes using multi-temporal and multi-instance angle SAR data. So if you just ponder upon this problem statement, it's quite generic. And this is what at least we really liked about this project, that it was very open-ended and there was like so many different ways to approach this problem, which makes it very interesting as well. And I hope that by end of this presentation, you know a bit more about the methodology and the design that we have chose for the ice cube, and hopefully you give it a try as well. One thing I want to touch upon just briefly is that data cube, when we talk about them, it's quite a generic term, and it can be quite subjective as well, depending on your context or depending on the application that you have been using. But for the sake of this presentation, we can consider data cubes as multidimensional arrays. And data cubes, generically, if we talk about them, they are information words that contain a lot of information. They're massive in size. And the idea there is that the user can easily jump in to a data cube, slice the information that they want. They don't really have to like load the whole data cube. They can just ask for some information, they get that, and then they are on their way. And that's what makes data cubes really magical, because you put so much useful information somewhere, but of course not all of the users want the same information. They want chunks of their information according to their requirements. One question might pop into mind is that, all right, so data cubes, they're magical, they're very nice, but why do we need them in the EO domain? I'm going to talk about a problem that is very well known in the Earth observation domain, and that is that a lot of big EO data is untapped. So the information, so the rate at which the data is being generated in with Earth observation or remote sensing it's not the same at which the data is being analyzed, and that's for a good reason. Because when we talk about the spaceborne data, it's not easy to analyze. There are a lot of caveats involved with this thing. For example, calibration, reprojections, and co-registration, and etc. That is why you need these EO experts who can actually help you to process the data and put them in a nice format, and then somewhere down the pipeline, and machine learning engineer like me can actually use it. Um, but the problem, and traditionally, actually, these remote sensing engineers or experts, they have been putting these guidelines as well for people to use it. But the problem with this approach is that the burden of this data processing, it shifts from data providers to data consumers. And the idea with their Datacubes is that we want to make sure that this burden, this responsibility of data processing, it remains at the data providers. So they basically process the data, they create nice analysis-ready data, and then they put it in the Datacube format, and then they ship it to the community. So community can easily use it. People who have no experience with the Earth observation domain, they can use it. And this is where we see a lot of value of Datacubes, that they bridge the gap between the EO domain and the community. And one thing I want to also mention here, that working with the spaceborne data is one thing, but if you're working with SAR data, it's just another thing, because it's like one layer more difficulty on top of the spaceborne data. So that's even more necessary to create the analysis-ready data for the community, in order to encourage them that you go and use it.
We have a question.
I think we can take that into. All right. So yeah. So now I'm going to talk a little bit about IceCube. So on the left side, you can see that we have a typical ICE stack. And if you're not familiar what stack is, it's basically we have an area of interest, or an AOI somewhere on the Earth. And as we go around that AOI, we acquire more and more images, and then the stack grows in the size. And here you can see that we have this slant range geometry, so we have the face information as well. And on the right side, you can see that we basically present the same information, but in kind of like data cube format. But also you can consider, or like you can imagine in the middle, that we do some processing as well. So taking like the individual acquisitions and concatenating them in the data cube format, and putting them in a nice data structure that the users can easily use. And the data structure choice that we have for the data cube, it's called X-array. If you look at the most state-of-the-art implementations of any data cube, particularly for machine learning, they actually use X-array as well. And that is for a good reason, because they work with the multi-dimensional arrays, and they support DASC for multi-processing, or to kind of like help to do parallel processing. So if we now put it kind of things in more perspective, we can see that we have this with X-array, when we're working with them, we have these individual data sets, which are also called like the data variables. So we have amplitude, we have phase, and then we can add as many data variables as we want. And if we zoom in into one data set, then we can see that we have this stack of data arrays. And this each data array, basically, it represents your one acquisition. So we take these acquisitions, we put them convert them into data arrays, and then we concatenate them under different variables, and we have basically the data cubes for with ICE data. As I mentioned, that for the data structure, we are using X-array. We are using DASC as well. One thing we want to make sure that any user can actually is able to generate massive data cubes using their ordinary laptop. And this is where the DASC really helps, because it does the chunking of your data into smaller tiles that fit into your memory, and then you can do the lazy operations on those chunks or tiles. And the DASC only loads the data when it's needed. Otherwise, it just keeps them in kind of like it just keeps the hash in memory. And then finally, we for storing our data cube, we are working with the NetCDF4 format. If you're not familiar with this one, it's just a wrapper on top of HDF5 with some improved features. And of course, everything that we're working in, it's written in Python. So I hope this kind of gives you an overview of, okay, we have this data that we are generating as we go around an AOI, and we have a stack growing, and then we basically represent the same information in the data cube format with a bit of processing in the middle as well. Yeah, and as I mentioned that we want to make sure that the data cubes that we generate, they integrate seamlessly into machine learning applications. And that is why we have also added like a sub data cube in the ice cube that is called the labels data cube. And the labels data cube, they contain the labels for your supervised machine learning models, both in raster and the vector format as well. And the idea here was that we didn't want user to work with multiple files. We want to make sure that we have only one pit stop where you can come and then you can access your X, or you can access your Y as well. So input and the output data. So you can easily index it, you can easily slice it along a dimension, and then you have the data that you want. And that was the motivation of putting the labels data cube as well. So you can have your SAR information, which is amplitude, phase information. You can also have your real complex data, as Agno will demonstrate in the example as well. Then you can also have your labels there as well. And then, of course, as I mentioned, we're working with Xarray. It works or integrates great with the NumPy and tensors. So if you can easily integrate it with your favorite machine learning framework, be it PyTorch, TensorFlow, or any other. And on the left side, you can also see that there's a user configuration. And this is where we want to make sure that we make it easier for the user to do basically the iterations or A/B testing. So if you want to do some seasonality analysis, if you're working with agricultural data or vegetation, then this can come really handy as well. So you can work with the temporal resolution. You can change it. I want to look at the data not one day apart, but a week apart or a month apart. Or if you want to look at the summer compared to winter season, you can do that as well. So you can change the start date and end date. And of course, you can also work with the incidence angles. If you have worked with SAR, you know that incidence angle is one of the most important parameters of SAR data. Depending on which incidence angle you get the image, if you have a smaller incidence angle, you will have a lot of backscatter from the objects. But if you have a bigger one, then your microwaves, they basically scatter away from the sensor and you will receive less of them. So the scene would be a bit more darker. And it gets very interesting to see how your machine learning model is dependent on the incidence angle. For example, if you're doing vessel detection, you want to see, okay, if I take the incidence angle from 15 degrees to 21 degrees, or like this kind of extreme angles from 31 degrees to 36 degrees, then how does my model behaves compared to a bit more nominal incidence angle range, which might be 25 degrees, 24 degrees. Yeah, so ice cubes with the user configuration, it makes it really easier for the user to access the information for the input and the output data, and you don't really have to like go out of this, and everything is pretty much pre-processed. You don't really need to, for example, do the back projections of the labels or go from map geometry to image geometry or the other way around. You have everything over there. You just start slicing the data, and then you can get ready with that. And this is something that Agno will show with the live demo as well. Yeah, and we have basically our GitHub repository that I will talk about just in a minute. Also, we have we have the website where we are talking about this, basically the landing page for the whole project. So if you are interested, we will be demonstrating some more useful applications, for example, flood mapping and etc. with the data cubes as well. So please stay tuned for that. Here's the team, and then also you can have a look at the first blog post that talks about the whole project and kind of like summarizes the gist. So you can please go to our website, and then you can have a look here as well. There's another blog post, the second one, which is coming soon. It will be within 2 weeks or so, and we will also open source that data set as well, so you can start playing with that. So I hope you can see my screen for the documentation. Actually, before going to documentation, let's go through the GitHub repository. So this is the one that we have created. One thing we have mentioned that, or one thing we have noticed is that when it comes to this kind of libraries, people do a lot of work on the development and the feature integration, but we don't have a lot of support for users to get started. And this is where we have worked a lot on MK documentation. we have tried to make it as simpler as for the user to pick up this library and start getting with this one. This is not meant to be a unicorn library. This is meant to be something that sparks for kind of like an ignition in the community to get started with the machine learning with the SAR data, so they can, so there's like this initial barrier or this gap that gets that gets reduced. And we are very much eager to hear from you guys. What are your thoughts about this one? If you like it, of course, give it a thumbs up and star as well. um, yeah, we're accepting pull requests. We're also accepting some features if you have any. And if I go into the documentation, I'm just going to spend like a few minutes here. So this is basically the landing page, the home page. We pretty much covered this in the presentation as well, but feel free to go through this when you have time. We have the guidelines for the installation. It should be pretty simple. So far, nobody have had any issues with installation, so it should be fine if you're using your pip or Python or Conda virtual environments. And then we have basically the 5 notebook examples that we have put together that talks about different examples. So the first one is basically how you can create a data cube that only works with the SAR data. So just working with the SAR information. The second example talks about, okay, how you can create the data cube that is specific to your labels. The third one, which I will go a bit more in detail, talks about what are the different ways to interact with the toolkit to create the data cube. The fourth one is a class that you can use to interact with the data cube. And the fifth one is an example that talks about how to spin your machine learning pipeline with the nice cube. Yeah, and here's the kind of like architecture diagram, kind of like a bird eye view that you can see. So here you can see that we have a primary like local ISI images. So you have primary image, and then you have the co-registered images, and then you have the user configuration and the labels in the JSON format. So you can take them, and then you can easily process them using this class. You can also work with the SAR data cube or the labels data cube, but these are kind of like base classes. So unless you are interested in the nitty-gritties, I would say you probably don't need to interact with them. Yeah. So yeah, if we talk about like this is probably the first thing that you will want to see. Okay, how to create data cube with the toolkit. There are different ways to do it. The first one is working with the CLI. So you can call the ice cube dash help once you have successfully installed it. So it takes into account the positional argument, which is basically your path to your local directory where you have the rasters, and option you can pass it the labels path as well if you want to get the data cube. That one, if you want to incorporate your labels as well, and finally you can save the data cube if you want. So these are pretty self-explanatory. As you can see, I'm executing them. IceCube GR directory, and it creates it. It gives me the dimension as well. So since we don't have a lot of time, I'm gonna try to expedite this as well. And then we also have this ISA process generate cube class that is kind of like a wrapper on these base classes that helps you to abstracts away those details, and you can pass it to your JSON file. And yeah, and basically you can see here that we have a cube configuration. So you have a configuration file. We have some samples that we have included as well, so you can have a look at that. You configure your configuration file, and then you just call the create cube, and then you have your directory. So it can be a directory that contains SLCs or GRDs, and then you have the cube configuration file path, and finally you can pass it optionally your labels as well, and then it creates the data cube. And then you can, and the data cube is basically an instance of this data cube class. So it has some nice useful methods and features that you can use. So here you can see, you can call the XR dataset, and it tells you about, okay, how the dataset looks like. So here you can see the coordinates, dimensions, azimuth range, or in the other words, X and Y. And this one is actually generated on a dummy data that we have included in the IceCube as well. And you can see your data variables. We have intensity, and then we have the labels as well. Yeah, and finally, there's another section that talks about the cube configuration and the importance of why do we need to why do we actually need to configure these parameters. They can be very helpful. So you can change your acquisition dates. So in this case, for example, you're going, I'm asking to create a data cube that spans from my 25th of April to 30th of April. And you can change more of fields as you want. You can change the resolution of in the time as well. You can have it 1 day or n day aparts. And then you can also work with temporal overlap. Do you want data from the same dates or not? And then finally, you can work with the incidence angles. So these are pretty actually quite exhaustive notebooks. I definitely encourage you to go through all of them and have a look. We have spent quite a lot of time on this one to make sure that you can easily pick it up. And finally, we have these data cubes for ML. Now I will hand over the mic to Agno, who will walk you through the live demo of how to use ice cubes with machine learning.
Sure. Yeah, thanks. So, oops. So as Irfan mentioned, like during the presentation, so during the notebook, so we have used like a sample data. So this is like 20 by 20 pixel. So the idea by doing so was to give the people the ability of like running the Jupyter notebook without the burden of like downloading 9 SLC or like 10 SLC or a stack of SLC, which can be like up to 50 gigs of data. But for today's demo, the goal was like to show like a real use case. So for today's demo, we are going to be focused on deforestation, and for this, we are going to use a stack of like 9 already co-registered SLC. I don't know if Irfan mentioned it, but the plan is also to just open source a way of co-registering our images. So the goal is like in the next maybe month to just like open source a container in order to co-register our images, SLC and GRT. So just to sum up, so during today's demo, we are going to go through like a segmentation machine learning process using IceCube. So which means that we are going to see how to load the data, how to pre-process the data, and then when we have pre-processed the data, how to visualize it. Because IceCube is not like directly made for machine learning. You can also like visualize the data very like easily. And then it's like how you can just integrate IceCube library into any machine learning library. For the purpose of the demo, we have used PyTorch, but you can do like almost any other like machine learning library. So let's start the demo. So as Irfan mentioned it, so there is like different way of like creating a data cube. So for today's demo, we are going to use the ICI process generate cube class with the default configuration, which means that we are not going to do any filtering, and we are going just and we are not going to define any temporal resolution as well. And by non-defining any temporal resolution, I mean that we are going to take the 9 SLC, we are going to stack them, and we are going to build the data cube. As you can see, it's like quite fast to load the SLC. So Irfan mentioned it, but we use Dask on the background, which means that like every time we are going to just load the image, we are going to do a lazy loading. But which means that we are going to load the data into our memory if and only we are going to use or load or save the data. Because for today's demo, we are going to use 9 SLC, as I said. So this is approximately 4 gigs of data. And we are going to use SLC. So this is the single look complex file for people on the call who are not familiar with like SLC and SAR in general. So the SLC is a product that is going to conserve the phase information. So in the file, we are going to have like 2 layers. We are going to have a real and the complex, and a combination of both are going to form the phase and the intensity. So now that we have created the data cube, which is called DC here, we can see what we have inside the data. So inside the data, we have a band, which represents the date. So for example, in this case, we are going to use like data from the 21st of July until like the 2nd of August. We have nine images. We have the azimuth and the range. So once again, if some people are not familiar with the SAR geometry, azimuth and range you can see as like the spatial coordinate x and y or lat and long. And we have the real and the complex, which represent like the real data and the value of the image. And also we have a label, because like IceCube is made for machine learning purpose. For sure, you can use it for visualize the data. You can use it for pre-processing the data. But the main goal is like to create a structure and infrastructure in order just to integrate into machine learning processes. And so when we have the data, so as ML process, basically, or like almost any like ML process, you will need like to pre-process the data. So for today's demo, we decided like to create like the intensity and the phase, which is like the most common like layer that you're going to manipulate with the SAR. And once again, using the advantage of using Dask, you can see that you can just load it and just create the layer like quickly. And it's due to the fact that it's not going to load and not going to do any computation until you are going to just like load the data or save the data. And as you can see that we have added like two different layers. So we have added now the intensity and the phase in our Datacube. Sorry. And so now as ML engineer or ML like enthusiast, you are like quite happy because you have your data and now you want to start like ML process. But first you need to visualize the data. And one advantage of using IceCube is like you can visualize the data and you can see what you have inside your Datacube. So the first one is like you can just slice along like the azimuth and range dimension, which means that you can slice along the spatial dimension, and you can do it like very easily, like using indexes. So, for example, here we are going to take like 10,000 to 15,000 pixels along like azimuth and range. And you can see that you can visualize the intensity, you can visualize the phase, and you can visualize the label. So in the case, on the use case of today, so the label represents the deforestation that happened between like the first image and the last one. So every time you are going to see a value of 1, the value of 1 means that the pixel have been deforested through the time during like the first image and the last image. But as we have the temporal dimension and the time dimension, we can do way more than like just a spatial slicing. So we can also slice along the time dimension. And this is like the power of like IceCube. Because we can just create like a kind of video of kind of like GIF of what happened between the first and the last image. And so if we are able like to take, for example, as we are able like to transform from the raster, we are able to go like to the Sloan geometry, we are able like to select interesting pixel for the video. But it's like also good like as a machine learning process. In a machine learning process, it's good like to load the data and visualize the data to see if it is okay or not. And IceCube is like really good for visualizing the data. So for example, here in this example, so we are going to slice along the spatial dimension, but we are going to show like each date, and each date represent one image. And as you can see, is like there is a change in texture that represent the area that have been deforested through the time and through the stack of images. And of course, you have intensity, but you have also and you have also the phase information. And what we wanted to show here is like the phase for a single image is not going to bring like so many information and not new information about deforestation. But the good thing is like as we are going to manipulate stack of images, phase can be like very useful in order to combine information at the stack level. And so now what we wanted to show is like, okay, now you have like, in like like a regular machine learning process, you will need like to pre-process the data. So what we did is like to create the intensity and the phase. You will need like to visualize the data. So you can just slice along all the dimension of the Datacube and just visualize the data. And now you need like a step further, and you need to see like how to integrate like IceCube into like a machine learning process. And so, and this is what we do here. So the dataset is a class made by PyTorch, and so the goal here is like to overload the dataset, and this is like normal to any is normal using like a PyTorch as machine learning library. You will need to do the same if you use TensorFlow. If you use Chaos, you will need to just like overload like the dataset class. And so the dataset class is basically an iterator where you're going to send the data as a batch. And so here in IceCube case, we can use Xbatcher. And Xbatcher is like really nice because it just allows to slice along all the dimension of the Datacube. So for today's example, we are going to slice along azimuth and range dimension. So we are going to use 512 by 512. This is like the basic input for neural network model. But I would like encourage you like to check it out, like our documentation. We have also other example because we can also slice along the time dimension. So for example, here as we slice along only azimuth and range, like the final output will contain the 9 images. So 9 in like the temporal dimension. But you can also slice along the time dimension. One good thing as well is like you can just create overlap into the data. So you can create overlap into the spatial, but also the temporal dimension. And it's like really useful. For example, if you worked on crop classification and you have you want one image per month, you can do it. And you can also slice, for example, as neural network input is fixed. You can also say, like, for example, I want like 3 months, so 3 images, and I want like the fixed spatial resolution as well. And so if we continue and just to see what we have in our data set, so as I explained, so we have 1 because we have selected a batch size of 1. I'm on my local computer, so let's stay like small in terms of batch size. We have like 2 layers, which is like the phase and the intensity. We have 9 in the temporal dimension, which represents our 9 images. And we have 512 by 512 that represent the spatial representation. And for the label, we have only 1, and we don't have any temporality because what we want to predict at the end is like only 1 raster that represents the deforestation that happened during the first and the last image. And so if we start visualizing what we have in our tensor, you can see, so we can just visualize the intensity of the first image, the intensity of the last image, and the phase. But the most important is like you can see like a change in texture in the intensity domain, and you have a label associated. And so if there is like any ML practitioner in the call, I mean, at least he talked to me. I hope it ring a bell for you as well. But it's like, okay, now I can start like creating my data set. I can start playing with the data, and start like modeling and just working with model. We know that like some people don't like to work online, but they also want to work offline. So you can just save your data sets as a normal data set on your disk. So if you execute it, you will be able to save your label and your data into your local disk, and like this you can just go offline and just like double check the quality of the data and just remove them from your training data set. So it's totally possible. So for this case, you can see the label. So the yellow area represent the deforestation, and the black one represent like the no change. And you can also see the data. So for each like sample or each tile, you will have the intensity and the phase. And if you go very quickly, you can see the intensity and you can see the phase. And the good thing is, like, if you want to work offline, you can also do it, and you can just work on it. And now that we have like created our data sets, we also want like to trigger like a training and a deep learning like training for segmentation for deforestation. Yeah. And so the purpose of the demo is like to showcase the advantage of using IceCube. We will not go like into the details of like deep learning about deforestation. Tapio Friberg have made a talk a few weeks ago about like what we did about deep learning and go into the details. So the main focus of the talk is like to focus really on the infrastructure and IceCube, and to show like how you can just like create like a pipeline of a machine learning pipeline, which means like you process the data, you visualize the data, you create your training and the test data set, and then now for any ML practitioner, they can just start working on like modeling and just like deep learning or any machine learning model. So for today's use case, so we are going to use a 3D convolution neural network. So instead of using like a 2D, we are going to use also the temporality. And the goal is like to predict like what happened during the first and the last image, and to predict the deforestation. So I trained like just before coming to the talk, I just trained like 10 minutes over like 2 epochs. And so I'm not going to run any model. But if you can see, here is like the output of the model. So here is like the actual mask, and here is like the prediction of the model trained over like the 2 epoch. So for sure, so it's not perfect, but it was really good that like in 50 minutes we have been able like to trigger a training, and now we are able also like to iterate over the model and just like to improve it. And we found it like very useful like to trigger like processes very quickly and just like manipulate a stack of SAR images. So hopefully the library is going to be also useful for you, and hopefully it's like the demo show you that you can maybe use our library in your current like processes. And I encourage you also to visit to just click and just like read the documentation, the GitHub repository, and I think it's time for, if you have any question, we will be happy like to answer any of your question.
Yeah, sure. So I think we got some nice questions. We don't have a lot of time, but we'll try to address as many of them as possible. Let's see. Okay, maybe not participants, but if you go to the question session. Okay, so the first question is, okay, is it possible to use the code for Datacube out of Sentinel images? So right now we support the ISI data out of the box. You can work with Sentinel, but it comes with a bit of limited functionality, so you cannot really do the cube configuration. So partly I would say you can work on it, but this is something that we will see if it's something that we have to put on our roadmap. Maybe the community can contribute on this part as well, but let's see. So the question is partly yes, partly no. And then so there was a question about probably the Datacube has already processed SLC data. If yes, how it was processed? Did you use some snap algorithms? So please feel free to weigh in as well. I think this should be pretty much
so we have
covered.
used like raw data. It hasn't been processed, but you can just pre-process the images online, and you can use IceCube like later into the process.
Yeah, and one thing I want to mention is we don't want to like tie the hands of the user to something. So something we is it that is on our roadmap is that we will provide this kind of functions that you can assign to your chunks in the SLC, and then you can easily process them. If we do a custom pre-processing, that it means that there might be better way to do processing, and we like just tying the hands of the user. So I would say it's good to explore as much as possible, but of course, but the functions we will definitely include them.
Yeah.
So if software was used co-registration, do you have your own developed software for this one? So for this one, we are going to have a Docker with that works with Snap. There's another one that you can also check. It's like the GFOC. That is an open source library as well that works on the spatial information to do the co-registration. But this one will use co-registration with Snap in the Docker. So yeah. Okay. Is it possible to read part of entire image into memory? I think this should be clear after seeing the demo, right? But yes, you can do that as you saw, as Agno showed as well. Is there a feature to get a geocoded result? Not at the moment, but yeah, this is an interesting feature request. We will see what to do about that in the future. And the next one probably, yeah, it goes to Agno.
Does the current implementation
Does the current implementation using XBatcher allows random batches on the fly?
Yeah, we just I think we face the exact same issue. Is like doing the batches on the fly is going to be like not as fast as like saving the data and like processing them after. So you can do it, but it's going to be like for sure it's going to be like a kind of bottleneck, and we have faced the exact same issue. So for now, we are going to use XBatcher to do the batches. But maybe later, if we just realize that it's not like fast enough, maybe we will think about like another solution to just like create it.
Yeah, and the last question is from Nicola. Could this work with INSAR data stacks able to compute all interferograms? a very good question, and that was one of the reasons that we wanted to keep the information not just in the ground range but also in the slant range as well. So you have the face information. So if you want to do for example analysis on the face and you want to calculate do the coherence analysis or even like interferograms, you can definitely do that. Yeah, thanks a lot. We again, as we mentioned, we are really excited about this one, and I think anything that you make great, it's not really possible by just getting inside the room and just writing all the features, dumping all the features. And this is where I think we really need the support or the active collaboration from the community. We want to hear it from you guys. What do you guys think? What works? What doesn't work? And then we can iterate on that to improve it and basically bridging this gap that we see there. Yeah. So yeah, thanks a lot for being here. Really great questions. I guess that's it from my side.
Yeah.
Do you have any final words?
No. Thanks for attending, and hopefully you find it useful, and hopefully you can just now see how to use it in your like current processes.
Yeah. Thank you. And hope to hear from some of you guys on the GitHub. So yeah, happy cubing.